Close your eyes for a second and try to picture a traumatic brain injury. What do you imagine happens to the brain inside the skull? Kind of a weird question. Maybe a few different things come to mind. But I'll bet that a lot of you think of this: a smack. We speak about concussions and brain injuries as if the brain is just smacking the inside of the skull, similar to how a ball would hit and bounce off of a wall. But that's not the full picture. So today, I'm going to fix that image for you. You know those weird Jell-O molds from back in the day? Gross, right? Imagine holding a delicate piece of that Jell-O in a bowl and shaking the bowl all around. It might just wiggle a bit and then return to its original shape. But if you shook the bowl hard enough and at the right angle, the Jell-O will ripple and undulate. It might even start to tear or break apart in some areas. My point here is, during a brain injury, your brain doesn't act like a solid mass, like a ball. It's a lot more similar to that Jell-O. I'm a researcher, and I study mild traumatic brain injuries, or mild TBIs. This principle is crucial for me to understand for my work. But it's also important for every single one of you to know. Why is that? Traumatic brain injury, TBI, is the #1 cause of disability across the entire world. In Canada, 165,000 people will get a TBI every single year. 90% of those will be mild TBIs, the kind that I study. That's 450 people every day, or one person getting a mild TBI every 4 minutes. That's a lot. And yet most of us are never taught what TBI actually is, what's happening inside the brain when it happens, and how to better protect our heads. Labs like ours have been asking these questions for decades now. We want to understand why some people who get a mild TBI have symptoms that take months or even years to recover from. First, let's talk about what a mild TBI actually is. A traumatic brain injury, or TBI, is an acute brain injury caused by mechanical energy to the head from external forces. So any force from the environment around you that acts on the head, if it's powerful enough, can cause a mild TBI. Often, these are direct forces. This is probably what you think of when you think of a brain injury. It's when something hits you in the head, say you're playing football and you go helmet to helmet with another player. But it can also be from rotational forces. See, our brains are actually floating inside of our skulls in a dense liquid that's meant to help protect it. When your body twists or accelerates at an abrupt angle, your brain follows along. It floats and shakes in that liquid, and a brain injury can happen even if your head never hit anything at all. A great example of this is whiplash, when abrupt movement of the neck back and forth is enough to shake the brain and cause a mild TBI, even when there's no surface to strike. So now you know a little bit about why a mild TBI might happen. How about symptoms? What do we know about those? The thing about mild TBI is that no two have ever been exactly alike. Every single one is different, and it all depends on how the injury happens, your unique genetic code, and other pre-existing factors about you, like whether you've had a brain injury before. But we do see a consistent pattern of symptoms across most of our patients. Some of the most common are headaches, nausea, mood problems like depressed mood or increased anxiety, trouble sleeping, dizziness, even changes to the way we see and hear. Another thing we find in almost every patient is cognitive deficits. These are issues with functions like memory, attention, and problem solving. When these symptoms happen and start to build up, everyday tasks become a bit more daunting and life gets more tiresome overall. Our lab is interested in knowing what happens in the brain that actually causes these symptoms. We're using brain imaging to try to track what happens in the days, weeks, and months after a mild TBI. We're still working on this now and it's not done, but here are some things we're pretty sure about so far. First, there is actually structural damage that happens to your brain after a mild TBI. It's just not the type of damage you can see on every single image. The cells in your brain are called neurons. Neurons communicate by sending electrical and chemical signals to one another. When a neuron receives a signal at one end, the length of the cell that the signal has to travel to get to the next one is called the axon. all around your brain, millions of axons are bundled together. They form these massive highways that shuttle information from place to place. These axon highways are known as tracts. Tracts in your brain and spinal cord connect all the different regions together, forming functional networks that work in harmony to let us do all the things we need to do every day. Tracts are what help you think, feel, communicate, move, see, hear, and remember things. In a mild TBI, these tracts are what's most affected. When force acts on the brain, your axons stretch and teeny tiny tears form all along them. These tears are very small, smaller than anything you could ever see with your naked eye. They're small enough that normally our body's built-in repair systems are good at fixing them on its own. But when mild TBI happens, the injury initiates a cascade of events that prevents this repair system from kicking in properly. Now, immune cells and molecules from all around the brain take advantage of these tears, the new entry points into axons. They rush into our neurons, causing the cells to expand and swell more and more until eventually they break. Yes, even a mild brain injury can cause your brain cells to break. What's more is, this damage doesn't happen right away, and it gets worse over time. You might look at a picture of someone's brain after a mild traumatic brain injury an hour later and see almost no damage, but check again a few days later, and you'll see tracts breaking down. Another misconception people have about mild TBIs is that they're kind of like a bruise, where only the parts of the brain that actually make contact with the skull are affected. Again, this is not true. If you looked at an image of a structurally damaged brain from a mild TBI, you would see tiny pockets of damage all over the different tracts of the brain. We call this diffuse axonal injury because the axons that are injured are in more than just one place. We believe that this diffuse axonal injury is the key to understanding most of the symptoms that we see after a mild TBI. When the tracts in our brains start to shut down the functional networks, that's when we can see physical, cognitive, and emotional problems. So, why don't we recap? When a mild TBI happens, forces that act on the brain cause your axons to stretch and tear. This makes tracts in the brain break down. Now, the brain has trouble talking to itself, and this can cause functional problems that stick. So, what can we do with this information? What comes next? Well, our lab is hoping that someday we can use the pictures that we're taking to predict what will happen to people after their mild TBIs. We hope that eventually we can take a patient who just got a mild TBI, tell them what kind of symptoms they're going to experience, and how long those symptoms are likely to last, so that we can treat them better in the future. But this research is also important on a more practical level because it reveals the risks that we take when we don't protect our heads. I have good news and bad news for you all today. The bad news is a mild TBI can happen to anyone, and it does. But the good news, the power of prevention is in your hands. Most mild TBIs are caused by accidents, so there's no one magical solution. But there are steps we can all take every single day to lower our risk of brain injury. Here's the part of my talk where I tell you lessons you've heard 1,000 times before. First off, wear your seatbelts. 15% of mild TBIs are caused by motor vehicle accidents. In a car crash, there's probably 100 different ways your brain could be injured. Seatbelts and airbags were designed to prevent literally every single one of those, so please don't take them for granted. Same goes for helmets. I know they look a little bit dorky. We all get that. But in the spring and summertime, the number of mild TBIs we see in the hospital increases because of bicycles, scooters, and motorcycle accidents. What about athletes? Again, helmets and protective wear are obvious solutions. But newer research has shown us that integrating neck and trunk strengthening exercises into an athlete's regular exercise routine is highly effective at protecting the brain against injury. With a stronger neck and core, your head is better protected against the rotational body forces that can lead to a mild TBI. It's important that we make sure that all athletes are aware of these things, especially kids whose brains are still trying to grow and develop. Smart training and safe play needs to be enforced in every single sport, particularly when you consider the fact that repeat mild TBIs put you at risk for a lifetime of problems. Life is both too short and too long not to be our best selves. The first step to taking better care of ourselves and everyone around us is to make sure our brains are as strong and as healthy as they can be. We can all be doing a little bit more to protect the jello we have up here. And when the risks are so high, I don't see why we wouldn't. So please, take it from someone who studies brain injuries. Protect your heads.